Excuse me, I need to teach chemistry. Excuse me. Excuse me. Come on, down you go. Goodbye. All right, sorry about that. You must be here to learn about single replacement reactions. Me too. You need a piece of paper, which you should already have, and something to write with, as well as the activities series, which looks something like this. So, on the top of your notes, you're going to write Unit 6. I'm going to scoot all this. You're going to write Unit 6. Notes. And they are going to be called single replacement reactions. Your learning target, I'm going to just abbreviate that with LT, is to be able to predict the products of single replacement, SR is the abbreviation, and then reactions can also be abbreviated with R, X, and S, reactions. Okay. So, first heading, SR reaction. So in an SR reaction, single replacement reaction, a single element replaces a second element in a compound. So we have a generic way that we can write single replacement reactions. That'd be A plus Bx, element A plus compound Bx yields element B plus compound AX. So A replaced B in this reaction to form a new element and a new compound. There are two types of SR reactions that we need to consider. The first type is cation replacement. So one is cation replacement. If you can remember back, our cations are always our metals. The things on the left side of the periodic table, the elements on the left side, tend to lose electrons, become positive cations. So, in cation replacement, you might write yourself a note that this is metals kind of doing the moving, if you will. It might be something like zinc plus copper chloride yielding zinc chloride and copper. It's the cation that is switching around. It's also the metal. So you might be able to guess that our second type of single replacement reaction is going to be an anion replacement. So these are going to be your nonmetals doing the moving. So in that case, you're going to look at your nonmetals. It might be something like bromine, one of our Hofbrinkels, so that's why it's 2 as an element, plus potassium iodide yields potassium bromide plus iodine, again a Hofbrinkel, so it's an I2. So in this case, it was the anion or the nonmetals doing the shifting. Okay. I'm going to go ahead and start a new piece of paper. And we're going to work on actually how do we do this learning target? How do we predict the products of a single replacement? How do we predict the products of a single replacement reaction? Okay, so we're going to have steps. So I might write steps for predicting SR reactions. Number 1, decide, does the reaction occur? If the reaction doesn't occur at all, which I'll explain to you in a moment about, then you're going to stop there. So if no, stop. Write no reaction. If yes, continue with the following steps. So number 2. Oop, I'm getting the wrong way. Is predict the products. So if the reaction occurs, I'm going to go on to predicting the products. Put the correct parts together, cation with anion, and check the charges. Also here you're going to watch for Hofbrinkel. Those diatomic elements might appear as an element in the products, and you need to remember that you need 2 of them. And then the 3rd step is to balance the equation. Balance the equation. So in order to do step number 1, this is where our activity series is going to come together. So I'm just going to go ahead and start using it rather than write about it. Let's just do an example, and we'll practice these 3 steps. So, example number 1. What if you have zinc plus hydrochloric acid, and you're asked to predict the products? So in step 1, we're going to decide, does the reaction occur? If no, stop. If yes, continue. This is where the activity series is going to come in handy. We're going to look and we're going to compare. In this case, we have a cation replacement because our single element is a metal cation that could possibly replace hydrogen as a cation. So what I'm going to do is I'm going to look and I'm going to see, is zinc above hydrogen on the activity series? If zinc is above hydrogen, then I am going to say the reaction occurs. You can see that this is organized with most active metals on the top here, with least active on the bottom. So if we go through and we find zinc, which is right here, and hydrogen down here, I'm going to say yes, this reaction occurs because the element zinc is above the cation in the compound. Notice down here it says elements cannot replace anything above them. The reaction does not occur. So if it had been vice versa, then we would say this doesn't occur. But since the element zinc is above hydrogen, then we're going to say yes, it occurs. So then we go on to step 2, predict. Put the correct parts together, cation with anion, check the charges, watch out for Hofbrinkel. So if I'm going to put these parts together, on the left I have zinc plus HCl, yielding. Now zinc's going to take hydrogen's spot, and hydrogen is going to become an element. So let's deal first with hydrogen as an element. It's H, but we have to remember that it's one of our Hofbrinkels. So it has to be H2. Whenever you come across hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, or chlorine, they have to have H2. They're diatomic as elements. So that deals with that one. And then over here we're going to have zinc with chlorine. Remember to check your charges. So you have to think about what is the charge on zinc. Zinc is always 2+. Chlorine is -1. When I cross these charges to produce the subscripts, it's ZnCl2. Sometimes these get a little messy at first, and that's okay. We're going to rewrite it now. Zn, leaving room to balance it in front of every reactant and product. And you could, oops, you can't see. You could do our steps where you divide, list the elements. If this one does jump out at you, though, you don't need to go to this trouble. We've got 1 zinc, 1 hydrogen, 1 chlorine. On the right, we've got 1 zinc, 2 hydrogen, 2 chlorine. Start by putting a 2 here. That becomes a 2. And then, let me tilt this up a tiny bit more. Then I'm going to also, looks like I need to put, oh, I didn't need this 2 here. Rewind, it's still 1. So I'm just going to put a 2 here and change that to 2 and that to 2, and now it's all balanced. 1, 2, 1, 1. Alright guys, I'm going to wrap this video up right now because I'm running out of time. But in a second you're going to play one more much shorter video where I just go over 3 more example problems.